spacecraft capable of handling satellite communications. In 1964, television viewers around the world were able to watch the Olympics from Tokyo. A visit to Mexico City by the Pope was also viewed globally. Over 500 million people, 1/6 of the world's population, saw man's first steps on the moon. Color coverage of space recovery operations from mid-ocean is now routine. At the Manned Spacecraft Center in Houston, doctors discussed space medicine and early cancer detection. The proceedings were telecast live via communication satellite and provided two-way voice circuits between the United States and 3 European countries. The closed-circuit telecast enabled 30,000 European doctors to hear the 3-hour transatlantic conference. One of the best ways to check out new concepts and techniques in communications, navigation, and meteorology is with research and development spacecraft. The applications technology satellites are just that, serving as platforms for testing out new concepts in all these disciplines. The ATS program consists of 7 flight missions. 5 of these have already been flown. Probably the most unique characteristic of the ATS is their ability to receive and transmit from a number of widely separated ground stations simultaneously. They can handle telephone calls, transmit television, teletype, radio voice, and weather data all at the same time. Keeping in contact with the SS Santa Lucia as it steamed between New Jersey and Chile, ATS demonstrated the feasibility of using satellites for high-quality, reliable, ship-to-shore communications over long distances. A similar test was made with a U.S. Coast Guard ship. ATS has been used to relay information from remote instruments and buoys, a step toward future data relay satellite systems. A successful experiment to transmit television by satellite from the east to the west coast took place with the help of the Corporation for Public Broadcasting.
These current tests are enabling NASA and the broadcasting community to iron out technical problems that are involved in this form of transmission and to determine the costs of such future operations. If these tests are successful, and we have every reason to believe that they will be, the American people will reap a major domestic dividend from the national space effort.
The program was relayed from a ground station in Rosman, North Carolina, through the ATS to KCET-TV, the educational station in Los Angeles. As soon as the receiving equipment is operating, Alaskans will have educational radio and television programs beamed to their state. Through an agreement signed with India, an applications technology satellite, similar to the one shown in this artist's concept, will begin telecasting instructional television into 5,000 Indian villages by 1974. India will provide the TV programs. The results of this cooperative experiment are expected to provide an understanding of the effectiveness of satellite systems in meeting the needs of other developing countries. A satellite-to-satellite laser communications experiment is also planned on future ATS spacecraft. Beams emitted by a laser can carry immense quantities of information. Communication satellites hold great promise for navigation and traffic control. Today, airplanes flying over wide open areas of the oceans are out of radio range for periods of an hour or more. The problem is compounded by the fact that most airlines going to Europe from New York, for instance, want to depart at 6 p.m. to serve dinner and show movies. They also want to go to the same altitude to take advantage of favorable tailwinds. The problem then of keeping international air traffic sufficiently spaced becomes more and more serious. NASA has been experimenting with a system to determine the position of planes and ships. The system makes it possible for a ground-based station to automatically locate aircraft and ships equipped with receiving and transmitting equipment.
Colored mobile number 2, pin in, Flipper 271. Position here from INS readout is 31 degrees, 32 minutes north, 70 degrees, 1 minute west. Flight level 330. This is 271, over.
In recent tests, position accuracies of less than 1 mile error have been achieved. Results of this work could lead to advanced techniques for satellite position fixing and traffic control, and aid in the solution of some of the world's transportation problems. Space geodesy has taught us the true shape of our planet, where it flattens, how much it bulges. With these results, we are better able to map the Earth and to navigate. The orbital path of a satellite is not a perfect circle. The satellite weaves sideways and up and down as it travels its course around the Earth. These deviations are measured only in feet, but they can be detected by Earth-based tracking stations and reveal new facts about the Earth's structure. Satellites have been tracked by laser. After predicting where spacecraft will be at any given time, telescope-mounted lasers swing into position, and aided by computers, their pulses of light lock on and track the orbiting craft. 3 of NASA's Explorer satellites carried special reflectors that mirrored the laser light flashes. The positions of the satellites were precisely determined, and the distance calculated simply by measuring the time it takes the beam to go to the satellite and return. Precision in satellite tracking leads to precision in terrestrial mapmaking. The Department of Interior estimates that the value of up-to-date topographic maps is worth nearly $700 million annually to our national economy. On the North American continent, surveyors have laid out a grid enabling them to locate any point with respect to another within 30 feet. There are similar grids in other well-developed countries, but they are not tied together. A surveyor cannot see over the ocean with his transit to make the connections. But a satellite can. It is a valuable tool because of its altitude. Observers several thousands of miles apart can see a high-flying satellite at the same time. By making simultaneous measurements with optical and radio tracking instruments, they can determine just how far apart they really are. The current goal of satellite geodesy is to tie all geodetic grids together to within an accuracy of 30 feet. Using high-flying satellites as geodetic markers, the world's continents will eventually be tied together to one common reference system. Geodesists also hope to use their new techniques to keep track of polar ice caps and glaciers, monitor the geometry of the ocean surfaces, increase knowledge of how earthquakes occur, and make direct measurements of the rates of continental drift. As the world's population continues to grow, our need to develop, protect, replenish, and use our natural resources wisely becomes more apparent and urgent. The air and atmosphere are resources of the Earth, as are the oceans, fresh water, ice packs, forests, minerals, and usable land. Efficient utilization of these resources not only includes their discovery and management, but also detection and control of pollution. In many areas, this need is reaching crisis proportions. Concerned citizens, private industry, state and federal agencies, all are seeking solutions to the problem. New techniques are being discovered to help. NASA has been exploring the use of both manned and automated spacecraft to develop the potential of flying instruments in space that will permit unique observations of the condition of our agricultural, water, forest, mineral, land, and marine resources. Much research has been done with aircraft, with information from existing satellites, And, of course, from the valuable photographs taken by the astronauts of the Mercury, Gemini, and Apollo programs. Based on this experience, it appears that the vantage point of space offers a number of unique possibilities for surveying Earth resources. The first two unmanned Earth resources satellites are planned for launch, one in 1972 and one in '73. They will provide a regular timber inventory of the Earth, identify crops, their vigor and yield, make automatic soil classifications, take photographs of the sedimentation flow patterns of the world's waterways, and help in locating mineral deposits. Here are some views recorded from planes and from Earth orbit by spacecraft. Better surveys of food and forest areas can be made from space, with computers distinguishing the conditions of the various types of crops and soils. Infrared photographs can show the onset of insect disease in forests. The damaged trees show up blue-green in color, the healthy trees red or pink. An Apollo spacecraft orbiting 150 miles over northern Australia spotted forest fires. Here are two others, as seen from space southwest of Tallahassee, Florida. By viewing fresh water from space, lake colors can be correlated with the biological, chemical, sediment, and pollutant content. Glaciers are another important source of fresh water, and their growth and decline are very sensitive indicators of the available supply. The Bureau of Commercial Fisheries says there is a close relation between fishery production and the temperature of the ocean, and they're very interested in having more accurate spaceborne instruments developed for monitoring these thermal conditions. This could significantly improve the efficiency of fishing fleets. Space photography can assist in mapping navigation routes in coastal and shoal water areas and help control silting in major harbors and navigable rivers. Ultimately, spaceborne instrumentation may permit observations of the wave heights of our oceans. Although it will not be possible to acquire all of the needed Earth resources data by sensors located directly in the satellites, it is possible to supplement the information by placing surface instruments, such as buoys, water gauges, and strain gauges, at strategically located positions on the surface of the Earth. These surface instruments could transmit the data to satellites, which would then relay it to central data handling stations. The Nimbus weather satellite is playing a role in ecology right now. A recording system on Nimbus was developed for an animal tracking experiment. Scientists attached a specially instrumented collar on an elk in western Wyoming. As Nimbus flies over, it receives information about the elk's condition and location and reports back to Earth. Accurate tracking of free-roaming animals in their natural environment will increase scientific knowledge of animal migration habits and may show ways to help protect our wildlife population. This is Skylab, America's first manned experimental space station. It will be launched into orbit around the Earth in 1972. There are several Earth observation experiments planned for the orbiting space station. One of the men who hopes to be flying in Skylab is scientist-astronaut Dr. William Lenore. He too is interested in Earth resources.
One of the more interesting aspects of what we can learn from space, I think, is the Earth resources area, which generally is tied up in the kind of things that I can learn from space by being in Earth orbit, looking back at the Earth from a remote sensing point of view. Meteorologically, we've seen many things already. We can learn about the Earth's surface from a crop survey standpoint, where the surface water is and the immediately subsurface water for the water management for the world. Pollution control and studies as to where the pollution is being emitted from and where it goes to. Fish industries for the ocean and sea states for ocean-going vessels, icebergs. I think these are just actually very few of the types of things that we can monitor and study from space on Earth resources. the Skylab program is going to be stepping off in this direction.
Bringing space down to Earth continues to make a substantial impact on our way of life. Communications satellites routinely provide reliable telephone service on a global basis. And important events are brought into our living rooms through intercontinental television. Coming close to reality, satellites that broadcast news, educational and cultural programs to populations of entire nations. Meteorological spacecraft aid in daily weather predictions. Satellites for navigation and traffic control will help make better economic and safer use of air corridors and oceans. Earth surveys from space should offer another means of preserving natural resources. We are sharing many benefits from space right now. As we develop this potential in the future, applications from space will have continued, profound, and direct effects on our everyday lives here on Earth.
One of the real key questions in our field of volcanology is to try to understand when is a volcano getting ready to erupt and when is something that we observe happening there just a natural process that isn't going to lead to eruption.
Deformation is often one of the first signs that a volcano is becoming restless, and then we also look for increased seismic activity. But the earlier that we can detect that deformation, the more we can refine what kind of a forecast we have and whether or not we need to be concerned about eruptions.
NISAR has a couple of capabilities that are going to be really transformative for volcanology. The first is the consistency. The fact that we're going to get these incredible data very consistently every couple of weeks. The other aspect of NISAR that's very important is its wavelength. It's got a longer wavelength than most satellite missions that have taken radars up into space, and that longer wavelength means that we're going to be able to penetrate vegetation and be able to see the ground through trees. We're going to get consistency, and we're going to get the ability to see through a lot of this obscuring vegetation, and that's really going to open the door for studies of volcanoes.
Because it's expensive and dangerous to put ground sensors around many of the world's volcanoes, many volcanoes around the world have no sensors on them or too few sensors to really understand what's happening.
Having something that's completely remote and satellite-based allows us to get an image of what's going on without needing to have something in the remote ground surface.
The thing about volcanoes is they could have a regional or even a global impact depending on the size of the eruption.
So it's really key to be able to understand how volcanoes work so we can better forecast their activity and warn people that might be impacted by eruptions.
Goodbye, Cassini, your mission's fini. Bravo, Cassini, have some linguini. You showed us Saturn's rings and lots of pretty things. Huygens probe took a dive early 2005. Landed on Titan, it was exciting. Your mission never failed to surprise, dazzled our eyes. Now dive to Saturn. Saturn vaporized.
In 1997, an ambitious international mission launches to Saturn that would, for the first time, attempt to place an orbiting spacecraft around the planet and land a probe on a moon in the outer solar system. But it was a mission that had to fight its way just to reach the launch pad.
Our Congress has had some agony over the program. We're going to have to operate under a very strict fund ceiling and an unyielding schedule.
We are all going to have to strive for, as we go through this process, is a continual search for the least unacceptable solution.
The journey to Saturn took 7 long years, and being captured into orbit depended on what would happen during just 3 hours.
We chased everything that could go wrong down the rabbit hole. We went down every path of, if this goes wrong, what do we do? If that goes wrong, what do we do?
All stations on net, SOI systems. Just an advisory, we're coming up on the time that the critical sequence will initiate the turn to the SOI burn attitude.
This was one of those moments where you're either in orbit or you're a billion-dollar flyby.
Flight is SOICOM.
Go ahead, SOICOM.
The Doppler has flattened out.
With Cassini safely in orbit, science quickly took center stage, beginning with dazzling images of Saturn's rings.
I'm surprised at how surprised I am at the beauty and the clarity of these images. They are shocking to me.
Investigating Saturn's iconic rings will be just one part of what will turn out to be 13 years of discoveries about the Saturnian system. And what will be realized about Saturn's moons will even transform how we think about our solar system and open up new pathways for the future of space exploration.
Around one planet, we find 2 moons that could potentially have the key ingredients to support life.
Triumph at Saturn. Next. For some scientists, the Saturnian moon Titan has been a higher priority for exploration than even Saturn or any other planet. That's because Titan may resemble what Earth was like billions of years ago, making this moon a kind of time machine that preserves in deep freeze many of the conditions that led to life on our planet. Titan is the only moon in our solar system having a dense atmosphere made mostly of nitrogen, just like the Earth. There are smaller amounts of methane and ethane that break down into organic compounds, creating the moon's smoggy orange haze. Titan's extremely cold temperatures turned some gases into liquids, which led scientists to wonder, could Titan have oceans, made not of water, but of liquid methane and ethane? These questions made the unmasking of Titan a major objective of the Cassini-Huygens mission. And before the release of the Huygens probe, Cassini would have the first opportunity to see this moon close up. With hopes sky high that the spacecraft might see Titan's surface, scientists were eager to share the 5-hour-plus flyby live with the world.
And you're watching live coverage from the Jet Propulsion Laboratory in Pasadena, California. Tonight, the Cassini spacecraft has its first close encounter with Saturn's largest and most intriguing moon, Titan. This is the closest we have ever been to Titan, and over the next 5.5 hours, we hope to see the best images we have ever seen of Titan. And here on NASA TV, you will see those images just minutes after they actually arrive on the ground.
And right on cue, the images began streaming down. But it quickly became apparent that Titan wasn't ready for its first close-up.
We have just received exciting word that we have the first image in. Okay.
As you can tell by the cheers behind us, we can confirm that the Dragon capsule with the AX-1 crew has splashed down. Dragon Endeavour has returned home with the Axiom 1 crew.
Dragon SpaceX, we see splashdown and mains cut.
We confirm.
The SpaceX recovery ship and team that you see there on your screen has been waiting for Dragon splashdown, and they're now making their way to that location.
On behalf of the entire SpaceX team, welcome back to planet Earth. The Axiom 1 mission marks the beginning of a new paradigm for human spaceflight. We hope you enjoyed the extra few days in space, and thanks for choosing to fly with SpaceX.
Sarah, to you, Ken, the team, and MCC, and all the teams that have supported us, all the engineers, technicians, great job at SpaceX. We're very grateful for the mission. Thank you.
All right, well, good calls there from MLA and Core.
And we copy all.
Crew excited to be home. All of us on ground happy to have crew back home. Now, the teams have been ready and waiting for about 3 nautical miles away, so it's going to take them about 30 minutes to make their way to get the crew inside Dragon.
So there we can see those 2 drogue parachutes, which were released, of course, first, and then, you know, they are let go in order to release the mains. That's what we see making their way back to Earth as well, of course.
The whole system comes back.
Yeah.
Sarah, we're in section 3. We think we're in stable 2. We can't see very well out the windows. Disregard, maybe that's stable 1.
And Dragon, your comm is getting pretty hard to hear. Maybe we can have Larry relay some of that.
Yes, Sarah, we're just confirming we've got fog freezing on the windows that we are in stable 1. Certainly feels like it appears to be.
Copy that, Larry, and can confirm we'd see stable 1 as well.
By the way, my thanks to you, everybody, all the people who have supported us around the world. Just amazing job and amazing mission.
Appreciate the words, Larry.
So that was our pilot, Larry Connor, also just expressing his thanks. Now we can see the Dragon capsule. So I just want to, kind of inform a little bit about what those calls were. So we heard the crew basically wanting to confirm stable 1, stable 2. So that's basically just the position that the capsule splashes down in. So stable 1 being this primary upright. Stable 2 would be like it's a little bit more on its side. Okay. And that's why they said, can't really tell, can't quite see out the window. Right. I have a feeling they were like, well, based on, the way that we're fitting in the sea, we think we're this way. So that's just confirmation of the position that false Quindar tone.
Yeah, false Quindars. You hear Quindars, you key up.
Yeah, so the recovery teams are now starting to approach the Dragon capsule.
Dragon SpaceX, we are go for recovery personnel to approach. You can expect personnel alongside in about 1 minute.
Perfect. So there's that safe approach call.
Understand, 1 minute.
Yeah, so the reason why the recovery team doesn't just rush there, so Dragon is loaded with hypergolic propellants, monomethyl hydrazine and nitrogen tetroxide, and they are toxic when you breathe them. Right. So for the safety of the crew, both inside and the recovery team, we wait for Dragon to basically double, triple check that all of those vents and everything are closed off and there's no venting from the Dragon capsule, like from those Draco thrusters themselves. So that's what that communication was in terms of making sure that we got the okay from the capsule,
Right.
and then Mission Control gave the okay to the recovery team. And we can see them there. There will be an individual that actually climbs on top of the capsule, and they are placing the harnessing and
the rigging essentially for hoist.
Exactly.
Okay.
The equipment that's required in order to lift Dragon onto the recovery vessel. Infrared shot there of that fast boat, as we call it, approaching, and they're basically doing another sniffing test, essentially, where you can see that the team has PPE on, personal protection equipment, respirators
Yeah, they got a respirator
to
mask
do
there.
a triple check that the vehicle is not releasing any of those toxic hypergolic vapors.
Right. As we mentioned earlier, this is a very coordinated maneuver, right? The weather has to be right. The area has to be clear. We mentioned how it's important that, other people are not in the area because this is, as Kate mentioned, you have the safety aspects of the hypergol that you need to worry about, but also just what crew is trying to do there. That's not an easy thing to do in the water. Having done a few boat maneuvers myself, it's not that easy to be doing what they're doing. So having the area clear for these teams to work and make contact with crew, but while also performing these maneuvers is really important. And you can see as well why we had to wait for such a super go for clear conditions and weather on a splashdown day. Even with nominal seas like that, this is an operation that takes a lot of attention and a lot of work on ground crew's side.
Now, one thing I want to mention, we have talked about Commander MLA Michael Lopez Alegria, how he has been to space before. This is the first time that he has made a water landing.
You're right.
So,
You're right.
he landed back on land with the space shuttle and the Soyuz.
Right.
So this water landing, we gotta keep it interesting, right?
Exactly.
Gotta get to do something new.
Yeah.
So there we can see one of the SpaceX recovery team members has climbed on board Dragon in order to start essentially equipping Dragon with the things that we need in order to lift it or hoist it up onto the recovery vessel.
Right, so on that note, Kate, looking ahead at some of the operations ahead of us, once the team is done rigging, the next big phases of this are really to bring a recovery ship. We're waiting for
Dragon, SpaceX, com check.
I have you loud and clear, sir. How many?
Have you loud and clear as well. Just wanted to verify a comm configuration update. For awareness, it appears we have a couple parachutes that are going to need to be towed out of the way for the recovery ship to approach. So there might be a slight delay to schedule, but we'll get you an update on timing soon.
Copy all.
All right, so on your screen, we could see the recovery teams basically lassoing the Dragon capsule in preparation. Now, we did hear a little bit of new information there from SpaceX Core, which is the crew operations and resources engineer, Sarah Gillis, just letting us know that a couple of those parachutes that came down with the Dragon capsule, that, once the Dragon capsule lands, we cut the lines to those parachutes so that, if there is a little bit of wind, the Dragon capsule doesn't get pulled along with the parachutes. Now, those parachutes, we do recover them, and we just heard some information there that we need to basically move them out of the way in order for that recovery vessel to make, the larger recovery vessel, the primary vessel, to make its way to the splashdown site.
Right, which you can see the team's doing there, right? Pulling some of the parachute out of the way. And it's a good call on Core to, have that comm check, and then let crew know, hey, there's been a slight deviation to the schedule, all nominal, all's good, but want to give you a heads up.
If I were inside Dragon capsule, I would really appreciate that information because, as we see how the ships, or excuse me, how those boats are moving and how the capsule is moving, that movement is a little less dynamic right now. But a couple minutes ago, I was watching the Dragon capsule, and I thought I would probably be feeling a little unwell, with that rocking motion. So, just for mental preparation and stabilization, knowing, all right, I might have 2 or 3 extra minutes to get through this.
Kind of acclimate
I can
myself
do this.
a little bit. I can hold on, right.
Dragon SpaceX for internal video.
Go ahead, sir.
If y'all are feeling up to it, request permission to come on board via the display camera view only.
Permission granted.
Copy that.
So soon we should be getting an internal view of crew inside the Dragon capsule.
For those that have just recently joined us, after 17 days on orbit, 15 of those days on the International Space Station, we can see that the Axiom 1 crew has returned home to planet Earth. Just a few minutes ago, they made their splashdown in the Atlantic Ocean off the coast of Florida near Jacksonville. And there we can see our recovery teams working the capsule in preparation for lifting it onto the recovery vessel. And there we have a shot of Mission Control Center here at SpaceX headquarters in Hawthorne, California, where John and I are located.
Yeah. You know what I particularly loved? Oh, there's a great shot from inside the Dragon. So this is just after splashdown now. We've got a shot over the shoulders of Commander MLA and pilot Larry Connor. So they're waiting inside the Dragon to be hoisted up now.
Yeah, we can see that they have lifted their visors, so that's the clear part there, which is currently on top of their helmet, but during the dynamic portions of the mission, so for launch, for docking, for undocking, and for splashdown, we do ask them to close their visors.
Right.
So now they're able to open it up and as we mentioned before, we have been flushing the interior of the cabin as well as inside their spacesuits themselves with cool nitrox, nitrogen-oxygen mixture, in order to keep the crew comfortable, throughout the recovery process.
It's amazing to me all the work that those suits do. Right, we were talking just what feels like a few days ago during launch about how those suits keep them cool. Even just from the drive from launch, from the launch pad, or from the suit room out to the launch pad and then up through the vehicle. But all the work that they do while on orbit and then coming back down. Earlier, Kate, when you showed the shot, or when we saw the shot of Mission Control during splashdown, for those who weren't able to join us while we were splashing down, I loved hearing cheers from everybody here. It was something I expected on launch day, but it's moving to hear it on splashdown too. It shows how many people are vested in the entirety of the mission, not just launching, not just on-orbit operations, but coming back to, a mission is start to finish.
Absolutely.
And that was really, really comforting to hear. Early Monday morning here, there were still people standing outside of Mission Control here.
Oh, 100%.
Cheering it on. I love it.
We wouldn't miss it.
Yeah.
Live view there inside Dragon Endeavour with the AX-1 crew. They have splashed down in the Atlantic Ocean, and the recovery teams are working to prepare the capsule for lift onto the recovery vessel. After Dragon is on the recovery vessel and fastened down, the teams will actually open up the side hatch and poke their head in and get a quick thumbs up from the crew, and one by one we'll see the crew egress or exit from the capsule using that side hatch. So once that side hatch opens, it's actually the first time it's opened since it closed on launch day, because in order to get on board and exit the space station to egress and all that good stuff, we use the forward hatch, the hatch that's at the top of the capsule.
But the nose cone was covering, right?
Exactly.
Yeah.
And the side hatch hasn't been open since launch day. So they got into the capsule on launch day. That side hatch was closed, and so when that side hatch opens today, it's their first breath of fresh air since taking off.
As we noted earlier, it's going to take a bit of time for the recovery vessel to make its way to Dragon. We got a call from Core saying that we had to get some parachutes out of the way so the ship can make a safe approach. But at this point, the rigging teams are working to make sure that Dragon is ready to be hoisted on that vessel as soon as it gets there.
Yeah, absolutely. As we've mentioned before, you heard us say it already today. You heard us say it a ton on launch day. Everything is carefully choreographed when it comes to space flight. The fact that the Core communicated to the crew just to let them know, hey, there's a slight delay, or you can anticipate a slight delay. It's all about safety is what it comes down to. The safety of the crew on board, as well as the safety of the support teams. In this case, the recovery teams there in the water with the crew.
Right.
That is priority number one above all else, and just making sure that everything is planned for step by step. And even in, I don't want to call the parachutes in the way off nominal, because that is a normal thing to happen, but it wasn't, we didn't plan for it, right?
Yeah.
So, for something like that where it's like, okay, the parachutes are in the way, cool, we have margin.
Dragon SpaceX for private medical conference.
And you have procedures for that as well.
Absolutely.
Go ahead with the PMC.
For awareness.
All right, so we're hearing that we're about 7 minutes out until we get to lift Dragon Endeavour onto the recovery vessel that you see there on your screen. The arch that individual there standing at the end of the ship, there's an arch above them, and that arch will actually articulate downward, and the teams in the water will attach the harnessing and everything required to hoist or lift Dragon out of the water and into that cradle there. Fun fact, that recovery vessel, that recovery vessel is named Megan after Megan MacArthur, who was our pilot for the Crew 2 mission. Our other recovery vessel for Dragon capsules, which, as we mentioned before, there's 7 sites around Florida. We have one recovery vessel here in the Atlantic, that's Megan. The other Dragon recovery vessel located in the Gulf is Shannon, for, of course, Shannon Walker, who was the first woman to fly on a Dragon capsule. So we have Megan and Shannon on board in our hearts, and of course in name here with our recovery vessels.
There we can see Megan making a slower approach now, coming up to Dragon Endeavour.
So once Dragon splashes down, there's a couple of fast boats. I should preface by saying that the recovery team is about 2 or 3 miles away from the splashdown site. For safety reasons, nobody can be super close, and so the team is situated close, but not too close. And those fast boats, the smaller boats.
Dragon SpaceX, I copied comm on the whining noise. Do you have any insight of when that started?
I think it started right at splashdown.
Copy that.
I was about to ask you about it. It's fairly high pitch, quite loud, and it varies in frequency a little. It's hard to tell if it's mechanical fan ventilation of some kind, or maybe some kind of vascular event. It's hard to tell.
So just a little.
Copy, Dragon. We hear it. Likely it is caused by a bilge pump that started at splashdown. We're going to attempt to power that pump off. Let us know if it resolves.
Copy.
All right, so just a little bit of interesting communication there with the crew inside Dragon Endeavour, as well as our team here in Mission Control. So when the crew was speaking, that was Commander Michael Lopez Alegria, the teams here were able to hear background noise. And so obviously the crew inside Dragon Endeavour are able to hear that as well. So that was just a little bit of back and forth describing where the sound may have been coming from or what it could have sounded like, and it sounds like it might be one of the onboard pumps that activates at splashdown.
SpaceX Endeavour, whatever you just did, stopped it.
Right. Good work
Copy
around.
all. It was the bilge pump.
There we go.
It's what we do. We solve problems.
Exactly. That's the life of a flight controller. Right?
Absolutely. So the recovery teams are, as I mentioned before, they're positioned close to the splashdown site, but a safe distance away. Upon splashdown, the fast boats make their way out quickly to do the initial safing and preparation of the capsule, making sure that the hypergolic propellants are not leaving any vapors around the capsule. And here we can see our recovery vessel, Megan, making its way slowly but surely to the capsule and its splashdown site. Once again, the capsule will be hoisted up onto the deck into that cradle. And in a very sleek and swift motion, that cradle moves forward toward the platform where we will see the crew egress and head into the medical bays. Once again, when that side hatch opens, it's the first time that side hatch has opened since launch day, which was back on April 8th.
First breath of fresh air since April 8th. And earlier, Kate, you were mentioning, every bit of this operation, for all of spaceflight, is safety first, right? And when you're this close to the finish line, it's even more critical to, follow those procedures, to
absolutely
take it slow and steady, right? Everybody wants to get across that finish line right now, but the mission's not over till they're safely back on board and you can open that hatch and get that breath of fresh air, right? So,
for sure.
Those fast boats make that initial contact, and Megan is coming up, in good time, following along with the timeline and making sure that we safely get Dragon back on board.
We can see that there are some swells in the water today, but the waves themselves are, almost non-existent. Really small waves there. We can see that skies are mostly blue with some clouds, as we mentioned before, with all of the weather factors that we take into account for, so things like precipitation levels, wind speeds, wave height, lightning in the area. And those are all factors that play into whether or not we get the go for undocking and the go for splashdown, which, over the last few days has been the the challenging factor for us. As we mentioned before, the crew was originally supposed to be in space for 8 days, ended up being in space for 17 days due to those weather restrictions, essentially, where we just couldn't get go criteria met for those various conditions.
All those variables have to add up to the right solution, right? And you can have one variable, it's great, we don't have a lot of wind, but if you have rain in the area, it makes it really difficult to do those 24-hour go, no-go calls. Okay, so right now it looks like we can see that the recovery teams are preparing to lower the vessel's hydraulic lift mechanism into the water, which will bring the spacecraft into the on-deck translation system known as the nest. So Dragon will remain in the nest during the crew extraction and for the journey back into port. And the capsule is currently being lifted and set on the nest. Then once it's centered and oriented, Dragon will then be translated into the hangar underneath the helipad aboard the ship so that we can open the hatch. Once open, a SpaceX medical doctor will be the first one in to check on MLA, Larry, Aton, and Mark and see if they are ready to egress out of the vehicle.
So we can see that hydraulic lift has been lowered, and they'll begin to hoist Dragon up onto the deck.
There's that crew member you mentioned who climbs aboard Dragon to ensure that the rigging gets established properly to pull the capsule back in.
Dragon SpaceX, brace for capsule lift.
One of my favorite parts of recovery is watching that individual. It's safe to say that, you know, recovery operations, there's a lot of training that goes into it, especially for that position.
Exactly right.
You know, to stay on top of the capsule as it's moving around and do everything safely.
And accurately, making sure that your hoist system is ready to hoist, right? Which we can see there now.
All right, so the Axiom 1 crew is now out of the water, making their way onto the deck of our recovery vessel, Megan. We can see some water splashing out there from the part of the capsule where the parachutes were stowed in. So that now is empty, with the side hatch just above. So that side hatch is where the astronauts will egress from. Before we open the hatch, the spacecraft's cabin pressure has to be equalized with the outside environment. And once the hatch is opened, like we mentioned before, that'll be the Axiom 1's crew first breath of fresh air since they boarded Falcon 9 at the very start of their mission just earlier this month on April 8th. So there we can see that the capsule is now seated in that cradle, and that cradle will then be pulled what looks like towards us, which is actually towards the front of the boat and closer to the base.
That ablative shield of the capsule, the TPS, you know, is sitting on what looks like a cradle.
Dragon SpaceX, welcome aboard the recovery vessel. Recovery personnel are completing final checks and stand by for translation to the egress platform.
Copy all, sir. We're standing by.
So we can see the recovery team there, once again doing testing to make sure that any hypergol vapors have dissipated, that the capsule is not releasing any more of those vapors. As I mentioned before, the propellants that Dragon uses on board, you know, it's different than the rocket propellants. The rocket propellants, we use our RP1 and liquid oxygen, and in order for those to burn, we have an ignition source, which is our TTEB. So, you know, it's like when you light a match, right? There's a flame or a spark, and it's different on Dragon. There is no flame on Dragon. The propellants combust instantaneously whenever they come into contact, that monomethyl hydrazine and nitrogen tetroxide. And they're super powerful. You know, that's why we use them on board Dragon for those Draco engines. But they are toxic if you inhale them. So we can see the crew there had their ventilators on, and they're just performing those final tests to make sure that the Dragon Dracos are not venting any of those hypergulls. It's pretty amazing to see. It has been amazing to see the pictures while the capsule was, on station. Some of them they don't look real. It's so beautiful, but it is real. And to see, images before splashdown and after splashdown, it's incredible because it just shows, how effective the materials are that we use on that thermal protection system. Right. As I mentioned before, we do replace the TPS for missions. That part itself is not reusable yet. So while on contrast, the interior, the bones, the structure of the capsule, that is reused. Right. So this capsule has now undergone its third recovery, having previously flown on the Demo 2 mission as well as the Crew 2 mission.
Yeah, it really is a testament to the capsule and just the refurbishment process, right? That really allows spaceflight to continue in this day is the reusability aspect. Seeing how clean that vehicle was at launch and still seeing 2 stickers on the inside, now seeing the third one and what it looks like coming back home. It's a testament to that ablative shield because you can see the energy that this is put through on its re-entry. So it'll be excited to see this go for the 4th one.
Yeah, absolutely. As we mentioned before, the capsule is going the same speed as the space station while it's on orbit, 17,500 miles per hour. And it slows down to about 350 miles per hour during that re-entry phase. And it's just really beautiful to see evidence of that. So just for a little bit of orientation while we have this view still, the bottom part of the capsule, that's where the heat shield is, right. And that's the part that was essentially facing or leading the capsule. So the capsule re-entered, with the bottom part first. The top part is the nose cone. That's the part that if you were,
Dragon SpaceX, capsule translation is imminent.
Copy imminent.
All right, so just a heads up there from core that the capsule is about to move or translate to forward. It's again just that communication to the crew because they can't really see what's going on too well outside the window. So just every step of the way, the core's responsibility is to give the crew a heads up of what to expect next. Yeah. So we heard the call out, brace for drogues, mains, splashdown, and here, for translation movement.
Yeah, really anytime crew is about to feel something, experience something, it's completely nominal, but you're right, without direct insight to it, it's really important for, core or Capcom in some cases to, play that role of letting crew know, heads up, you're about to feel something.
Yep, and of course, while crew, they're monitoring the timeline all on their own, having that, as we mentioned before, confirmation of the choreography is important.
Yeah.
So we can see that side hatch really coming into view now. Situated there in between the 2 windows. Just a recovery harness there in front of it, which of course, will be moved.
You can see a good dual view inside the capsule. As on the right, you have teams still in respirators working on the entry aspects of the Dragon, ensuring that it's safe and ready to be open from the side hatch. While crew on the left side is, you can see over the shoulders of MLA and Larry, awaiting for those ground teams to make ingress.
see the crews there still wearing their PPE or personal protection equipment.
And if you followed along during launch, similar to crew ingressing the Dragon for the first time, there is a whole team of people on the ground supporting these efforts. Likewise, during splashdown, there's an entire team of people on the ground supporting recovery. So as the vehicle, not only is recovered from the water and is passed onto the boat, it's then handed off to people on the recovery teams who have very specific roles.
As we mentioned before, the interior for Crew Dragon, that air pressure has to be equated to the external pressure, so that, that's what's going on. You can see now the crews have taken off their PPE.
Dragon SpaceX at 36 minutes and 25 seconds after splashdown. We are go for side hatch opening. Stand by for hatch opening and egress.
Excellent.
We are watching the clock.
I think they're more than eager for that first breath of fresh air about to happen.
All right, looks like that side hatch is open.
Excellent.
Flight surgeon stepping in there to do a quick check with the crew. That white piece of framing there is a fixture that we'll put inside the all right, we can see the recovery crews there inside the Dragon. Yes, we'll put that piece of fixturing around the side hatch just to protect it while the crews are, getting out of the capsule now. All right, so just the recovery crew there giving a quick reminder to the Axiom 1 crew how things will go down in terms of, egressing or exiting the capsule. We have said this before, this is something that has been rehearsed. The team practices getting in and getting out of the capsule. But, just a quick rundown, they've had a dynamic day.
Exactly, exactly. It's nice to have the reminders, and it's good to just say, hey, we're almost there, but a few more steps to go before we get you out. But regardless, welcome home.
This view here, we have the commander, MLA, on the left-hand side of your screen, and pilot Larry Connor on the right-hand side.
This view, you can see a few more of the ground team members just doing some final assessments and checks on the vehicle prior to crew egressing through that side hatch. camera making way to see our crew for the first time there. All waving, all in good spirits.
See a bunch of thumbs up.
Welcome home, AX-1.
Lots of smiles on board.
It's always good to see.
So on the far left there, mission specialist Mark Pathy. Next to him we had pilot Larry Connor, then to the right MLA, and on the far right Eitan Stiba. For Mark, Larry, and Eitan, it was their first trip to space. MLA had been to space previously, but as I mentioned before, this was the first time that he returned to Earth via splashdown, so new experience for him.
Returning home on an Endeavour, but splashing down this time instead of runway landing, right?
That's right. I believe you said earlier that he flew on Space Shuttle Endeavour.
Yeah.
Was it STS-113?
Yeah, that's right.
Yeah.
That's right. Which, awesomely enough, is parked here in LA. And we got to go see it the other day.
It sure is. So the recovery teams are just preparing the side hatch there for the crew's egress.
That's that white frame you mentioned earlier?
Absolutely. So just a fixture there to help protect that side hatch during this process. As we said before, this capsule has been reused. We plan to reuse it in the future. So not only to protect the crew themselves, but also the hardware.
Yeah. I imagine that's the sealing mechanism, so you want to protect that as you're walking over it and making sure it stays pristine.
All right, so that was the footrest that we saw coming out. These detach from the seats in order to allow the crew to get out of their seats a little easier. Also helps, just increase the usable volume inside Dragon. John, you and I were in the training capsule. Yeah. It's about 2 weeks ago now.
Yeah.
And it's definitely makes a difference in terms of small things like that, which seem like a small or a thin item that doesn't really take up space, but in reality, in terms of the volume that it occupies and where in that volume it is placed, it does make a difference in terms of mobility. And when you're on orbit in microgravity, it's a lot easier to get around than when you're stuck here on Earth with that pesky gravity. Yeah.
Pesky gravity. Right, and I don't know if it's the same for egress, but during launch we noticed that there was a very particular way in which crew and ground teams had to ingress the vehicle because of those volumetric constraints. But allowing those footrests to come out does free up space a little easier. It's been, they've spent a number of days in orbit, haven't felt the effects of gravity in a while. So making it as easy as possible to egress the vehicle is really important, not only for their comfort, but also for everybody's safety.
It looks like pilot Larry Connor might be the first one to exit the vehicle.
See on the left-hand shot, the right side of that screen.
So inside Dragon capsules, we use a 5-point safety harness. So a little bit more complex than the seatbelt you and I use in our cars. it's really designed to be safe, make sure that the crew's ergonomics or their, the positions that their body is in during the dynamic portions of the mission, that they're strapped in properly, but also so that they're comfortable.
Right.
So it seems like that's what the recovery teams are now assisting the crews in unlatching, is that safety harness.
Right.
So we can see there Larry Connor starting to make his way out of his seat and onto the deck there on our recovery ship, Megan.
See Larry making his egress from the Dragon Endeavor. You can hear the cheers in the background for it.
All right, those are his first steps back on planet Earth after spending 17 days on orbit. If it were me, I imagine I'd probably feel a little shaky, right? Because they don't have gravity up there. They did take exercise equipment to keep their muscles working while they're up there, but still, it's.
There, we're going off comm. Thanks for everything. We'll see you on deck.
Sounds good. Talk to you later.
My last call there from MLA to say that they're no longer going to be utilizing the Dragon communication systems. They'll just talk with everybody on the deck.
So there we saw mission specialist Mark Pathy. He was seated on the far left, or at the left window seat. All right, removing the footrests on the other two seats.
Like you said, Kate.
I have a feeling Aton will be next.
Yeah.
No, it looks like it's MLA.
Yeah, that's certainly part of the reacclimation process, is remembering those muscles that help keep you stabilized in a 1G environment. You haven't used them in a few days, so it's certainly time spent after coming back home.
Oh, just kidding. All right, so MLA did a little change of seats there, so Aton will be the next one to come out. It's very, that feels very on par for him. We've heard that MLA really was an exemplary commander for this crew, and he basically just said, no, Aton goes first, I'll be last.
Yeah.
One of my favorite phrases is leaders eat last. Make sure everybody else goes first, and it's just great to see that.
Yeah. See Aton making his egress and first stance back on ground in 17 days.
Yeah, it's quite the readjustment coming back down to Earth and going from, regardless of how long you're up there, obviously it's, the longer you are, the more difficult the transition can be.
Yeah.
But even after the 17 days that they were in microgravity, that's still a pretty significant change on the body.
Yeah, it certainly is.
So it's pretty amazing to see them, just take those steps and begin that reacclimation process.
Exactly.
Now, once they are, so for the 3 crew members that we saw exit or egress the vehicle already, they walk off and they are immediately escorted into one of the medical bays that's on board. So the recovery vessels are fully equipped with medical bays to assist with any ailments or illness that the crew might be feeling at that time. It seems like everybody was in really good spirits and everybody was feeling quite well. But that capability is on board the Dragon capsule. And so basically the crews just go in and get checked out by the flight surgeon and get those thumbs up.
Yeah. Just that capability to have that immediate assessment is really important. Even if you are feeling perfectly fine, you're taking your great steps, it's all part of the ground-based operations that ensure that you come home safely and you get out of the capsule safely.
So there we saw MLA slide down the ramp and now standing. Welcome home, Commander MLA.
With that, all 4 crew members of AX-1 are now safely out of the Crew Dragon Endeavour.
So you can see there mission control here behind us at SpaceX headquarters in Hawthorne, California. Checking in now that pretty much all the dynamic activities of recovery have concluded.
Right. At this point, we'll just be waiting on crew to make sure that, they have those good checks that you were talking about. Making sure that all the medical checks coming out of the vehicle, they're happy, healthy, feeling good.
Yeah.
All right, well, as the crews are now safely aboard the recovery vessel and have completed their journey to the ISS and back, marking this moment is Axiom's Chief Business Officer, Amir Blackman.
Thank you. John, Kate, and the Axiom and SpaceX media teams, thank you for that wonderful coverage so we could all share in this. The AX-1 mission is one of the more visible milestones of our journey to ensure that space travel is opened up to more and more of the brightest minds and eager explorers from around the world who want to make our home planet a better place. And we believe this mission, represented by the US, Canada, Spain, and Israel, advances that vision of a unified humanity reaching for the stars. Despite the strife going on the ground, the ISS crew and our astronauts continued working together as a beacon of international cooperation. In the years preceding this mission, we at Axiom Space set out to develop the procedures, foster the agreements, and build the operations and support teams needed to expand what had historically been negotiated only between governments. And with every step, we've created new precedents. We set the bar very high for ourselves, and we asked a lot of this crew. And here we are at the conclusion of an incredible mission, and I must say the teams exceeded every expectation. We could not be more proud of what has just been accomplished by Commander Michael Lopez Alegria, Larry Connor, Eitan Stibe, and Mark Pathy, as well as the hundreds of team members who have played a part in the success of AX-1. Over the course of this mission, we've succeeded in inspiring those who seek to pursue a place among the stars. Over 400 interns applied for the 23 openings at Axiom. 5 additional